Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today we've got Vedang who has just completed the course Linux Basics for Robotics. So he'll be giving us a presentation on that. So as usual, we'll begin by seeing a demonstration of his code base running on the real robot, and then after that we'll ask him to get into the details about what he did and how he did his project. So let me now hand over the platform to him so he can begin his presentation. Alright, whenever you're ready, Vedang.
Yes. Am I audible and visible on the screen?
Yes. Hello, Vedang. Can you hear me?
Yes.
Alright.
Is my screen visible?
Yes, it is. Yes,
I'm connecting with the robot.
Alright. So let me double check something quickly.
Okay, so I'll wait for the bot to be visible first.
Okay.
Once it is visible, I will run the real robot bring up commands. It's connecting. Now it's connected and bring up screen.
Alright.
ROS running. Now here I'll access my directory. Once I'm in this directory, I'll check what all files I have here. So basically I have obstacle avoider, then robot interface, robot statistics, and simple petrol.bash. And all of them are executable as they are green. So first I'll run the robot interface file.
Yes.
Once it's ready, I'll run the obstacle avoider file. Ready. It's running. In a new terminal, I'll run robot statistics here.
Mm-hmm. Try using tab, it will probably help you.
So as you can see in the above this terminal, I can see the left range, front left range, front range, front right range, and as I have set the threshold to 0.3, it will check all the ranges and see whether it is free or not. So in this example, I can see front range as greater than 0.3, front range also greater than 0.3. So it will move forward. If it detects less than 0.3, it will decide whether to move it right or left.
Mm-hmm. Okay.
And the code below for robot statistics, it is showing me the distance covered since the start, position of robot on x-axis, y-axis, z-axis, orientation of the robot.
Mm-hmm. Okay.
Now it will again check for left and right ranges, front left, front right range.
Mm-hmm.
So front left and front right is all of them are less than 0.3. So it will check for left and right ranges, and whichever is preferable, it will turn in that direction.
Okay. Okay. All right. Can you now show us your code base and you explain what's going on there?
Should I stop the simulation? Sorry, the real robot
yes, please.
presentation, or?
Yes, you can stop it.
Object order file. Here I have firstly the shebang line. It basically tells our Linux system whether this file or this script is a bash script or not.
Mm-hmm.
Then we have the source robot functions.bash. This robot functions.bash file has all the getter and setter functions in it,
Mm-hmm.
which will be required in the code further.
Yes.
Then echo will print the statement on the terminal, running name obstacle avoider with bash script. And again, press Ctrl plus C to terminate, as it is a while loop and we have not provided any false statement in it. Everything is true. So in order to terminate it, we need to terminate the whole process by pressing Ctrl plus C. So the whole program terminates.
Okay.
Then setting the command velocity, linear velocity to 0 and angular velocity to 0. So the bot is at rest. Then threshold, I think the threshold value as 0.3.
Mm-hmm.
As I'm a beginner, I didn't define any functions, but I have an idea how I can define it, which I will explain you further.
Okay.
Then as the while loop starts, first I have mentioned all the 5 scan ranges. Here is the left range.
Mm-hmm.
Left range, this LL underscore range is a variable, and the get scan left range is mentioned in the robot functions.bash file.
Right.
So it is taking the function, and this particular $sign stores it in the LL. So whatever it will return a particular value
Yes.
that will be stored in error range. And
Okay.
whenever I have to access it, I
Mm-hmm.
will access it using dollar LL underscore range.
Oh.
So I get the particular value.
Mm-hmm. Okay.
Similarly, it went on for front left range using this function,
Mm-hmm.
front range using get scan front array function, and echo is basically printing the
Mm-hmm.
line.
Okay.
Front right and right range.
Mm-hmm. All right.
After that, I'm checking the frontal scan ranges. So if I want to check front left is free or not, I'll pass this condition. Front left range is greater than threshold.
Mm-hmm.
So basically my threshold value is 0.3.
Mm-hmm.
If my front left range value is greater than 0.3, it will return me 1.
Yes.
Uh, so basically that 1 will be stored in front left free.
Mm-hmm.
Then I will echo front left free. If it is greater than 0.3, it will return me 1. So we will get 1. Or if it is less than 0.3, we will get your 0 as
Mm-hmm.
response.
And what is the purpose of
S-
the stroke L that you've got? After the pipe operator, you've got pipe operator, then BC stroke L.
BC-L. I researched about it. According to me, it is basically a math library for Linux calculator, something which can work for decimal places. If you have many decimal places or floating point numbers, it can work with it.
Mm-hmm. Okay, so if you can tell me what does BC represents, what does it represent? Because the flag L does represent something. What about BC?
Uh, PC, yes, it is something like a calculator, but generally for floating point numbers, I guess it has been used. And dash L is for the library.
All right, all right. Yili, let's go on.
Okay. Similar was done for front free. FF range was accessed if it's greater than threshold. If it's true, it will return 1. If it's false, it will return 0.
Mm-hmm.
And similar for front right.
Right. Okay.
Then comes the 8 different cases for frontal scan ranges. So the very first case in which we are saying that front left is not free as it is equal to 0. Front is also not free and front right is also. Then in this case, we will check for the left range and right range.
Mm-hmm.
If this particular value left range is greater than right range, if this is true, we need to print as this is if statement, we need to print turning left and setting the angular velocity to 0.331416.
Mm-hmm.
Else,
why do you set it to 0.31416? What was the
basically,
logic behind it?
I tried to iterate it, but I decided to compare it with the simple petrol.bash, which file was provided
Mm-hmm.
to us earlier. And I took the same value. I tried iterating it, but I thought whether it would overshoot or something. So I kept the same value.
Yes. So when you
Uh,
changed it, what did you see? What did you see when you tried different values for that number?
I tried putting 0.2 something or 0.1. The bot was turning less, which was preferable, but again, I decided to keep the same value as the petrol, simple petrol.bash, just to be
Mm-hmm.
according to the how the petrol.bash file is working.
Mm-hmm. Okay.
But according to me, 0.3141 turns a bit more, so I prefer to.
All right. And if you were going to alter the way you, let's say, what other parameter would you change? Let's say you wanted to control how much angle the robot turns, right? Without touching angular velocity, which other parameter would you change to allow that variation of the amount of angle it turns?
Without changing the angular velocity.
Yes, without changing the angular velocity.
And the robot statistics.bash, I will find for some function which is related with the changing of angle something.
What about in this script? What about in this obstacle avoider? What did you change? Say that again.
No, sorry, I don't have idea about that. For
Alright.
changing the according to me, if I change the angular velocity, then only then the bot will turn, right?
Yes,
Uh,
yes. So
if we have any other function for it,
no,
we
not
might.
necessarily. Not necessarily. There are two ways you can control how much your robot turns, right? So you understand that you can make it turn for a particular amount of time on a fixed angular velocity, right? So
Yes.
that says that you can either control the time or the angular velocity, right? So if you reduce the amount of time and keep the angular velocity constant, right? That's the kind of logic I
Okay,
was trying to
huh,
get.
right,
Yes,
right. Yes,
that's what I
yes.
was trying to get you
If
to think
we,
about. Um,
okay, okay. So we are setting the angular velocity same, but we will toggle time to
yes, that's why I was asking
that.
what would happen. What happened when you changed the number, and is there any other way you could have done it? All right, but enough
Oh,
of that bit. Let's go on.
so else, if left is less than right range, it will turn right, and angular velocity is minus 0.3. So minus basically turns it in the opposite direction.
Okay.
And then fi basically what I noticed from the simple petrol.bash file was if I'm using an if statement in order to terminate it, I need to write fi. So it closes the if statements. And then sleep is for this the delay for providing time delay so that the robot turns left and right. And the next command is not followed until this sleep time is
All right.
completed.
All right. All right,
Uh,
Fadang. I think we have got a clear understanding of what you did here. So I thank you very much for your presentation. And unfortunately, we are running out of time on this one. So you just
okay.
hang on. But thank you so much for a wonderful demonstration. So just
Yes.
hang around and then we'll be Alright everyone, this was Vedang's presentation and would like to thank him for getting the courage to come and present, and would like to encourage all those of you who would want to give a try to this project to do so, and then you can come and show